What is the blue area? Label points A, B, C, D, E, F, G, and H. Join line B, G. Hence, the area of the inscribed red square A, B, H, G equals the sum of 1 and 3, which equals 4 square centimeters. Let the area of triangle B, H, G be equals to A1 and the area of triangle B, E, GB equals to A2. Let us first find the area of polygon EGH, which equals the sum of A1 and A2, where A1 equals half the area of ABHG, which equals 2 square centimeters. Let the side length of the red square ABHG be equals to x. It implies that its area, 4, equals the square of x. Take the square root of the equation. X equals the square root of 4, which equals 2 centimeters. Consider triangle AFB. Area equals half the product of line AF and line AB, which equals 1 centimeter. After substitution and simplification of values, cross-multiply and we have that line AF equals 1 centimeter. By Pythagoras' theorem, the square of line BF equals the sum of the square of line AF and the square of line AB. Substitute values. It follows that the square of line BF equals the sum of the square of 2 and the square of 1, which equals to 5. Take the square root of the equation. Line BF equals the square root of 5 in centimeters. It implies that line GF equals line AG minus line AF, which equals to 1 centimeter. After simplification of values, let angle BFA equals theta. It follows that angle GFE equals theta. Consider similar triangles AFB and GFE. Line GF divided by line EG equals line BF divided by line BA. Substitute values. Hence, 1 divided by line EG equals the square root of 5 divided by 2. Cross-multiply and we have that line EG equals 2 divided by the square root of 5, or the product of 2 and the square root of 5. All divided by 5 in centimeters. By Pythagoras' theorem, the square of line BG equals the product of 2 and the square of line BH. This implies that the square of line BG equals 2 times the square of 2. Take the square root of the equation. We have that BG equals the square root of 2 times the square of 2, which equals the product of 2 and the square root of 2 in centimeters. It signifies that from triangle BEG, using Pythagoras' theorem, the square of line BE equals the square of line BG minus the square of line EG. Substitute values and we have that the square of line BE equals 8 minus 4 divided by 5, which equals 36 divided by 5. Take the square root of the equation. Line BE equals the product of 6 and the square root of 5 divided by 5 in centimeters. Hence, area of triangle BEG. That is, A2 equals half the product of line EG and line BE E which equals to 6 divided by 5 in square centimeters. After substitution and simplification of values. Since line B, E is the side length of the larger blue-white square, let its area be equals to A3. It implies that A3 equals the square of B, E which equals 36 divided by 5 square centimeters. Hence, the area of blue region of the larger blue-white square equals A3 minus the sum of A1 and A2 which equals 36 divided by 5 minus 16 divided by 5. The result equals 4 square centimeters. Therefore, the blue area equals 4 square centimeters.